The Doppler effect was described in 1842 by an Austrian physicist named Christian Doppler. He observed that the pitch of a sound would change if the source of the sound was moving. He tested his observation using trumpet players standing on an open railroad car. He had the players maintain the same note as the car moved past the stationary observers, who would record the notes they heard being played. And as predicted, the observers heard lower notes being played as the real car moved further away.
The Doppler effect is due to the relative motion. Since the waves are moving at a slower or faster rate relative to the source of the waves, the wave and the wavelength remains the same, we experience the frequency at a faster or lower rate.
Pitch in relation to waves. The shorter the pitch, the higher the sound of wave of pitch you're going to get, versus the longer the wave is, the lower sound of pitch you're going to get. So, in relation to the Doppler effect, what that's going to do is, whenever you say a car is all the way over here and it's coming towards you, you're going to experience a wider wavelength of sound you're going to hear. So that's going to create a lower pitch, but as the car comes towards you, that's going to create a higher pitch because the wavelengths are going almost constantly at a shorter area. And then as it goes away from you again, those wavelengths are getting longer again, causing a different pitch at a lower frequency. So, but say you're in the car and you're making the sound, it's going to sound exactly the same no matter where you are because you're at the epicenter of that sound.
Good. Okay, so as the helicopter approaches the observer, Erin, the pitch and the frequency increases, so it appears as if she is hearing a higher note than is actually being heard.
Yes, it's very loud.
Yep, you can hear this helicopter. And so as it gets further away from her, the sound waves get further apart, and so the pitch is lower, and the tone that you hear is lower than the actual tone.
Very smart.
Yeah.
They see me mowing.
No? Okay.
So Madeline, explain the Doppler effect to me.
Okay, Richard.
I think I have a bad connection. Hello? You got a video of me getting hurt?
Yeah. Okay, the Doppler effect was described in 1842 by an Austrian. I need Anne, not A.
Doppler effect. I can. It's like right behind me. Just walking. Okay. With the Doppler effect. Okay.
Described in 1842 by an Austrian physicist named Christian Doppler. He observed that the pitch of a sound would change if the source of the sound was moving, just like we are. Yeah. And so he tested this observation using trumpet players standing on an open railroad flat car. He had the players maintain the same note as the car moved past stationary observers, and these stationary observers would record the notes that they thought they heard being played. And as predicted, these observers heard lower notes being played as the car got further away from them. We're good.
Play on, R-I-C. See me roll on my Segway. I know in my heart they think I'm wise.